Hi, Assalamualaikum. This is a project about MEMS speaker electrostatic actuator. From this, we use two material and two parameter for the upper block, which is called a device material. This result about the directional deformation. Directional deformation can assess the quality of the material properties that touch in the design. Okay, we use the material nickel and the silicon, and the parameter we use a 50 micrometer and 30 micrometer. You can use to see the table the result is going from. Okay, these are the deformation parameter for the upper block. These are or the conclusion achievement for reference electricity actuator, MEMS speaker, actuator simulation and analysis using NCS tool. And lastly, for the channel deformation, the parameter variation would affected. That's all.
This electrostatic actuator is comparing the different material which is nickel and silicon. It also comparing the value of parameter of upper block inside of 50 micrometer and 30 micrometer. This part explains the result of equivalent elastic strain. The project show different result if using different material and different size. As shown, the nickel 50 micrometer and 30 micrometer is different at the device layer. The maximum and minimum value is located at different place, while the silicon 50 micrometer and 30 micrometer is located at the same block device. Normally, the higher the value of time, the higher the value of micrometer. If the ventilator is used 50 micrometer, the value of output maximum and minimum get increased, and when the material is used high parameter, the value of maximum and minimum will follow to get more higher. As conclusion, the equivalent elastic strain is very important to get the perfect design for this project. The changes of material and parameter of the body affect the graph obtained in the project. The variation of parameter in different type of material will affect the equivalent elastic strain.
Assalamualaikum. For this project, the main material for this project is silicon and nickel. For the figure 1, it shows the 7-step NCs for static structure are complete. The input for this project is force. As you can see, the minimum to maximum force for silicon and minimum to maximum force for nickel. The SI unit for this project is Pascal. The output is the equivalent stress for nickel and silicon. At figure 2, it shows the result equivalent stress nickel when maximum force applied at the positive y-axis. Then the figure 3 shows the result equivalent stress silicon when maximum force applied at positive y-axis. Then we move to the figure 4. The figure 4 shows the recorded data for simulation result. Figure 5 shows the graph for equivalent stress nickel versus force and equivalent stress silicon versus force. For the discussion, we use silicon and nickel as a substrate because it's a good and more stable. Next, silicon is better in 30 micrometer and nickel better in 15 micrometer size. Height total equivalent value will determine the material properties is strong to support the design. Then, the equivalent stress must low to avoid the structural failure. For the conclusion, we achieve our target to design this actuator, run the simulation, and analyze the result for MEMS speaker using NCS software. Lastly, the variation of force will affect for equivalent stress.
I will continue the presentation with the strain energy analysis. When an elastic structure stretch, it stores an energy known as a strain energy. The strain energy is a source of the potential energy obtained in a structure component because of elastic deformation. In the simulation, we have varies the material and the length of the surface where we have applied the force to generate the strain energy output. The first material we use is the silicon, and the second we use the nickel. We also have vary the surface area with the 50 micrometer and the 30 micrometer. From the graph 1, there are major difference when the length of the surface has been increased. we can see the big difference between the 50 micrometer and the 30 micrometer in the graph. The conclusion from the analysis, we can conclude that the material and the length of the surface will affect the strain energy that been generated. That's all from me. Thank you. For the part to implement our device in order to combat the COVID-19, our device can be used to improve the speaker or the hailer that been used by the local authority to spread the information about the COVID-19. Example of the improvement can be made by the MEMS electrostatic speaker. First is the size. We can reduce the size or the body ratio of the device so it can easily be carried by the local authority. The second, improve the quality sound. The development in the sensitivity and noise will improve the acoustical performance of the speaker and will improve the output sound. Eventually the sound became more clearer and can outspread compared to the conventional speaker. The third one, to improve the power consumption. Even though the MEMS speaker require higher voltage level compared to the electrodynamic speaker, the overall power consumption is the lowest. Thank you. That's all from me.